So I had some requests to record a tutorial about how to interpret the results section of medical studies, and this arose from some Facebook inquiries. So I'm going to do my best. So if you are actually medically trained, forget about some of the terms that I'm using because they may not necessarily be accurate. So this is aimed at people who don't have any medical background training. So let's get started. So the main thing that you're looking at is a lot of raw numbers in studies, and quite often there are all these numbers on the side of a raw number that seem to indicate whether or not a result is significant or not. So just with some broad concepts to start off with, the null hypothesis when you're looking at an intervention or looking at comparisons between the groups is that there is no difference between a treatment that you gave versus a placebo or a control. So most studies, they're trying to actually prove an effect of some sort. So in effect, you're trying to reject the null hypothesis. And there are several ways to reject the null hypothesis. The eye test is extremely variable. So if you look at, an outcome of a group of people treated and look at an outcome of people who weren't treated, and you say, oh yeah, that looks roughly about, 50% less than the other group and so forth. There's no way of actually applying any kind of rigor as to whether or not that result is purely by chance or whether or not it's so-called statistically significant. So what we'll go through is what a p-value is when you're comparing attributes in a study. We'll look at ways to calculate relative risk as well as confidence intervals, and then look lastly at odds ratios in association with confidence intervals. So if we have an example situation where in COVID-19 you got people dying and people surviving, one of the ways to do interpretations is to set up a 4x4 table where you've got one thing happening like a trial drug and one thing where it's just normal treatment, so a placebo or a control group. So if we just say that this particular study had 100 patients in each arm, in the trial drug group, you had 50 people died, 50 people survived. In the placebo group, 80 people died and 20 people survived. So you can look at that for the eye test and say, well, that looks like a pretty good result. But in order to make it statistically significant, there's a few tests that you need to do. So we'll go through what is the risk reduction from this trial drug, what's the odds ratio of being on the trial drug, and are all of the above statistically significant? So the first concept is a p-value. There's several different tests that can be done to generate a p-value depending on the type of data that you have. So if you're able to generate a 4x4 table, then one of the tests is a chi-squared test, but we won't go into that. There are lots of other tests. We'll leave it at that. So if you think of p as a probability, and the probability you're looking for is that the result you achieve was either purely by chance or actually due to the effect of the intervention that you were treating. And the most common threshold that's reported for statistical significance is less than 5%. And we'll have a quick look at how you achieve that 5%. So the bottom line is when you're looking at medical studies, and it's got that value on the side that says p-value, when you're looking for significant results, look for a p-value that's less than 0.05. So that's the first step. Look for a p-value less than 0.05. The next thing is, what is a confidence interval? So this graph, or this picture here, is what we call a normal distribution curve. So let's say if you did this study with a trial drug and you did it on 100 different populations, most of the time the effect that you would get would be somewhere in here. But sometimes, for whatever reason, you might get an effect that's closer to this side, you might get an effect that's closer to that side. So the results spread themselves in a normal distribution if you simulate doing this test lots and lots of times. So the 95% confidence interval basically means that you remove the theoretical 5 most extreme results from either end. So 2.5 from the lower end, 2.5 from the upper end, and this gives you your so-called 95% confidence interval. So let's apply this to this all of these tests to this supposed trial drug that we had. So if we did a chi-square test, and there are many different calculators online that you can do this for, The chi-square calculator on this set of data says that these results, there's less than a 0.01% chance, less chance that the results were due to chance alone. So the p-value works out to be less than 0.00001. Okay, so that statistically tells you that this result is significant. Now, I just want to show you what happens if you reduce the sample size. So it's exactly the same kind of ratios, 50-50, 80-20. I just made it 5-5 and 8-2. But if you apply the chi-square test to this particular table, you find that the p-value is 0.16. So that means there's a 16% chance that these results are due to chance alone. So in medical studies and literature, you try to make sure as much as possible that the result that you're getting is not due to chance, which is why you set it at a pretty strict 5%. Now, you can set it anywhere you like, but if you set the p-value at 0.5, it's not a very good kind of threshold to set it at, because you're accepting up to a 50% error. But on the other hand, you don't want to set it too strict, so set your p-value at 0.01 or 1%, because that means that nearly all the time it's going to be very difficult to prove that your intervention is actually achieving anything. So sample size actually matters, as you can tell from this. So the next question is, how do you assess the risk reduction of some kind of intervention that you're doing? So let's say we've got a given outcome, death from COVID-19. So that's the bad outcome here. Certain interventions like a drug might decrease your risk of dying, like the trial drug. So if we look at the risk, your risk of dying from COVID-19 on the trial drug is 50-50. The way to calculate it is 50 on both of these together. So 50 on 100, 50%. Whereas if you're on the control drug, a placebo or control group, your risk of dying from COVID is 80%. So that's 80 on 100. So your odds, we said 50-50 is a common term we use, but your odds is actually slightly different to your risk. So the odds is 50 divided by 50, which is 1. Your odds in the placebo group or the control group is 80 on 20, which comes out to 4. So that's the basic premise of risk assessment. And now the next thing is how you work out risk reduction. So your absolute risk reduction is basically the risk of your placebo group, 80%, minus the risk of your intervention group or the trial drug. So that's a 30% absolute risk reduction. So if you're wanting to work out how many people you would need to give the drug to in order to prevent one bad outcome, in this case, dying from COVID-19, this NNT is the number needed to treat, and it's 1 on the absolute risk reduction, which works out to 3 1/3. So that's absolute risk reduction and number needed to treat. They're linked together. If you're looking at the relative risk of the trial drug, that's 50% on 80%. So that's a 63% risk of the trial drug compared to if you took nothing, or the placebo group. Now where it's a bit more complicated is what's the relative risk reduction of being on the trial drug. And that's your absolute risk reduction on your baseline risk. So in other words, your absolute risk reduction we worked out was 30% over your placebo risk, which was 80%. So therefore your relative risk reduction of the trial drug turns out to be 38%. A lot of people confuse risk reduction with the odds ratio. So I just talked a lot about risk reduction, but the odds ratio of the drug is actually the odds of the trial drug group divided by the odds of the placebo or the control group. So that's 1 1/4 or 0.25. So these are all just raw numbers that I've generated, but how do we know whether or not these are statistically significant? So we'll go to that in a second. So the significance of risk reduction methods. So p-values and 95% confidence intervals are what we are using in order to determine so-called statistical significance. It's pretty self-explanatory for risk and risk reduction. In other words, if your 95% confidence interval for a risk of 30% lies between 10 and 50%, they're all above zero, so therefore it's a statistically significant result. It's a little bit more complicated for odds ratio, where the confidence intervals must not include the value 1 to be significant. So let's say all of these different people did the same trial in the same manner as what we described. So they gave a trial drug for COVID-19. Smith and his colleagues got this odds ratio of 1 and a bit, and you can see that the confidence interval spreads from 0.5 to 2.6. So that crosses the threshold of 1. That means there's a chance that there's no difference between the drug and the placebo group in that particular study. And same with Jones et al. He almost achieves significance, but you can see the left-hand side just touches 1, so that's not quite significant. And same with Smith et al. Again, he must have tried again to get some statistically significant result, but he didn't quite achieve it either, because the 95% confidence intervals at the lower end still crossed 1. Whereas these other two studies were significant in that their 95% confidence intervals were nowhere near 1. Now, if you look at a group of studies put together, so a meta-analysis of some sort, and you pull all of these together, we mentioned before that sample size matters, because now you can see that there's an effect here, and 95% confidence intervals for all of these studies together does not cross 1. So it's a fairly strongly significant result in this particular case. So let's look at this slide here again and put what the 95% confidence intervals were for all of them. Okay, so absolute risk reduction was 30%. The 95% confidence intervals was 17.5 to 45%. So that's got to be a significant result, because the lower end is still greater than 0. And the relative risk reduction, once again, greater than 0% at the lower end. So therefore, it's a significant result. Now, the odds ratio of 0.25 with your 95% confidence intervals 0.13 to 0.47, which means that it is definitely significant in that 1 is not even close to either end of that. Okay, so that's my summary of the necessary tools that you need in order just to interpret the results section of medical trials, because I'm not going to explain stuff about methodology and various statistical tests that are used to generate these. Thank you for your time.